Light. Now, let's do this question. First thing I like to do is I like to use variables. So let A represent first stop light, and B will represent, let B represent second stop light. B represents second stop light, then let C represent third stop light. And so what we need to find out now is they're telling us that the probability that the motorist stops at the first stop light is 0.2. The probability that he stops at the second stop light is 0.5. The probability that he stops at the third, so there's a very high chance of him stopping at the third stoplight. That stoplight probably change every 3 seconds or so. So maybe every 10 seconds, so it's very highly that he will get stopped there. It says find the probability he stop at only one stoplight. So if he stop at only one stoplight, so the probability he stops at one stoplight, the probability of stopping at one stoplight is going to be equal to, there are many ways to find it, but this is the approach we're going to take. It's going to equal to the probability that he stops at A, but not others, plus the probability that he stops at B, but not others, plus the probability that he stops at C, but not the others. So if the probability of stopping at one stoplight is going to be equal to, if he stops at A, the probability of A is 0.2, and if he didn't stop at B, that's 0.5 times, if he didn't stop at C, that's 0.2, plus the probability that he stops at B is 0.5, but he didn't stop at A is 0.8, plus he didn't stop at C, which is 0.2, plus probability he stops at C is 0.8 times, if he didn't stop at A is 0.8 times, if he didn't stop at B is 0.5. And so the probability he stops at one stoplight is 0.2 times 0.5 times 0.2 plus 0.5 times 0.8 times 0.2 plus 0.8 times 0.8 times 0.5, which is 0.42. So there's a 42% chance he stops at only one stoplight. So that's part one. Now what's the next part now? It says find the probability he stops at two stoplight. So to find the probability he stops at two stoplight, so the probability he stops at two stoplight. To stop at two stoplight means we can find the probability that he stops at A and B, plus he can stop at maybe A and C, or it can be he can stop at maybe B and C. So it's either once it stop at two, it has to be two. You can stop at either A and B, or you can stop at either A and C, or you can stop at B and C. That's going to be the probability of him stopping at two stoplights. So that's going to be equal to The probability of stopping at A and B is probability of stopping at A 0.2, not stopping at B 0.5 times probability of not stopping at A is 0.2, stopping at B is 0.5, not stopping at C is 0.2, plus probability of stopping at A and C is 0.2 times not stopping at B is 0.5 times stopping at C, which is 0.8, plus the probability of stopping at A is 0.2 times probability of stopping at B is 0.5 times the probability of stopping at C is 0.8. That works out to be 0.2 times 0.5 times 0.2 plus 0.2 times 0.5 times 0.8 plus 0.2 times 0.5 times 0.8. That's 0.18. So there's an 18% chance he's going to stop at 2 stoplight. Now part B. Part B says, use the data of the following to estimate the mean. So before we can estimate the mean, I want to come to just put down that table here. X and F. One, two, three, four. Let's work with this now. And we have X. Here it's going to be from 5 to 9. Over here it is 10 to 14. Over here it is 15 to 19. Over here it's 20 to 24. All right, and then here is F. The frequency is 8, 4, 10, and 3. All right, now all we need to do is draw another table to represent the midpoint. So now we need a midpoint. So I'm going to call this XI. This is midpoint table. The midpoint is going to be 5 or 4.5 plus 9.5 divided by 2. So the midpoint table will be 7. Then right here will be 12. Then right here will be 17. And then right here will be 24 plus 20 divided by 2, that's 22. Now you might be wondering, why do I want to know that? That's because that's how we're going to find the mean. The mean is given by bar x, and bar x is equal to the sum of f times xi divided by the sum of f. That's how we find bar x. So what does that mean? That means that the mean is equal to the sum of f times x, means we need to work out what is 8 times 7 plus 4 times 12 plus 10 times 17 plus 3 times 22 So that's the sum of f of x, and all of this is of course being divided by the sum of f, and the sum of f is just The sum of f is just the 8 plus the 4 plus the 10 plus the 3. And so let's work it out. Put all of this in a calculator to get what is bar x. So you work it out, 8 times 7 plus 4 times 12 plus 10 times 17 plus 3 times 22. That's 340. 340 divided by 8 plus 4 plus 10 plus 3, that's 25. So 340 divided by 25, nice and easy. 340 divided by 25, which is 13.6. And so that's the mean, 13.6. 13.6. One thing I want to point out is notice that the mean, notice that it occurs in the interval that have the highest frequency. Generally, the mean, the mode, and the median will occur in the interval with the highest frequency. Not all the time, but most of the time. That's when the data is symmetric. So what we're saying then is the mean or the average, the mean is equal to 13.6. Now part C now. Part C says, research in a town shows that if it rains on any one day, then the probability that it will rain the next day is 25%. So if it rains on one day, right, so we're going to start with rain. So rain, right, so it have a normal day. If it rains today, the chance it rain the next day will be 25%. So we have rain, then given that it rained, then the chance that it rain the next day. So I'm going to write R for rain again. The chance of it raining again, let's say it's 25%. Just want to make sure that's right, 0.25. So if it rained first, then the chance of it raining the next day is 0.25. And then this is now no rain. So I'm going to write NR for no rain. So there's a 75% chance it doesn't rain the other day, right? Then it says, if it does not rain one day, then the probability that it will rain the following day is 12%. So we have rain, and then we have no rain. I'm going to put it as 1 soon. Then we have no rain. We have no rain. All right, and saying if it have no rain, then chances of it raining the next day, they're saying it is all right, no rain is going to be raining. If it does not rain, then the chances of it raining the next day is 0.12. And so if it don't rain, the chances of it not raining the next day is 0.88. So let's see what the question says. The question says, draw a probability tree diagram to illustrate the information. So of course, we're going to have to put this as one big tree diagram. So we need to put it as one big tree diagram. So generally, it starts from either rain or no rain. Think about it naturally. So one big tree diagram is either it rain or it don't rain. Either it rain or it don't rain. So either it rain or it don't rain. Chances of it gonna rain is a half, and chances of it don't rain should be a half. naturally. Now, given that it rained, then chances of it raining again the next day will be 0.25. This is for the chances of it raining again. And given that it rained, the chances of it not raining is 0.75. This would be no rain. All right. Now, right here, so now is given that it don't rain, then chances of it raining is 0.12. This is for it to rain. And then chances of no rain is going to be 0.88. So that's part A. Nice and easy. Soft. So this is part I. This is the tree diagram. This is the answer for part I. Now the question says, given that it says determine the probability it will rain on Wednesday of the week. Starting on Monday and given that it rains on Monday. So they're telling us that it rains on Monday. So if it rains on Monday, so it rains Monday. All right, it rains Monday. And what do we want? We want the probability that it will rain on Wednesday. All right, so the probability it will rain on Wednesday, given that it rains on Monday. Given that it rains on Monday. So we need to find the probability that it rains on Wednesday, given that it rains on Monday. Now the probability that it rains on Wednesday, given that it rains on Monday, is going to be equal to the probability of it rain on Wednesday. Probability of rain on Wednesday, given that it rain on Monday, is equal to the probability that it rain on Wednesday. So this is a conditional probability. The probability of A given B is equal to the probability of A intersect B divided by, and this is divided by the probability of divided by the probability of B, the probability that it rain on Monday. All right, so we need to find this. What's the probability that it actually rain on Monday? All right, now the probability it rain on Monday in actuality is 0.5 times 0.5 times 0.25. If it rain on Monday, because it says it rains on Monday. If it rains on Monday, it is this. It rain on Monday. The chances of it raining on Monday is 50%. All right, so this works out to be chances of it raining on Monday is 0.5. Now, the chances of it raining on Monday. So given that it rain on Monday, we want to find what's the chances of it raining on Wednesday. So if it rain Monday, so the chances of it raining on Wednesday and on Monday, we need to find out what's the probability of it raining on Monday. Now think about it, the probability of it raining on Monday and Wednesday, so it can rain Wednesday, right? It can rain Wednesday, but don't rain Tuesday. So what we're saying is it can rain Wednesday, but no rain Tuesday, and rain Wednesday, or it can rain Wednesday, rain Tuesday, and rain Wednesday. Those are the two possibilities, don't it? That's a probability it rain on Wednesday and it rain on Monday. So let's find that. Let's find out those. Let's do it that way. So the probability that it rain Monday, don't rain Tuesday, but rain Wednesday, it's going to be equal to. So one find the probability it rain Monday, don't rain Tuesday, but rain Wednesday. So rain Monday is 0.5. Let's type it. That's going to be rain Monday is 0.5 times no rain Tuesday. If it don't rain Tuesday, so rain Monday, this is Monday then Tuesday. Rain Monday is just 0.5. Now, given that it rain Monday and don't rain Tuesday is 0.75 times for rain Wednesday again is 0.5 plus the probability that it just rain Monday, rain Tuesday, rain Wednesday. So that's just 0.5 times 0.25 times 0.5. Nice. I'm getting 0.25. So there's a 25% chance it will rain on Monday and rain on Wednesday, given that it rain on Monday. Nice. Now let's go to the final question of the paper. Question 8. Question 8 says, a particle is moving in a straight line with a velocity of 3 meters per second at t equals 4 and 4 seconds later to a velocity of 9. It says show this on the graph. So this is the graph sheet of how it's going to look. So this is what you're required to do. So it says a particle moving in a straight line has a velocity of 3 meters per second at t being 0. So this is 3 meters per second right here. When t is 0, it has 3 meters per second. And 4 seconds later, its velocity is 9. 4 seconds later, its velocity is 9. This is 4 seconds later. Velocity is 9. All right? So this is it. So draw on the answer sheet provided, draw a velocity time graph. So you draw your velocity time graph like this. That's your velocity time graph from 3 meters per second to 9 meters per second. So let me put that there. This is 3. This is 9. Nice. What else they ask now? They ask to calculate the acceleration of the particle. Now, acceleration of the particle is the gradient. All right, so just find the gradient. All right, so acceleration A, the acceleration is going to be equal to y2, which is 9, minus 3, which is 6, over x2, which is 4 minus x1. So the acceleration is 6 over 4, which is 1.5. That's the acceleration, 1.5 meter per second square. That's the acceleration. The increase in displacement over the interval from t being 0 to t equal 4. To find that distance, it's always area under the graph. Now the area under the graph, this is a trapezium. This is a trapezium. So total distance is the area under the graph. So the area under the graph is going to equal to a half the sum of the parallel sides, which is a half 3 plus 9 multiplied by perpendicular distance. This perpendicular distance going this way, that perpendicular distance is 4. And so that's equal to a half of 3 plus 9 times 4. And so the area of the trapezium is, that looks like 12, 48, 48 times a half, that's 24. That's the area of the trapezium, 24 meters. Nice and easy. So that's the distance. Area of the trapezium is 24 meters. Soft. The acceleration is equal to 3t minus 1. So if the acceleration is 3t minus 1, it says now the particle has a velocity v of 4 meters per second when t is 2, and a displacement x, which is 6 meters when t is 2. Find the velocity. To find the velocity, velocity v is the integral of the acceleration. So v is equal to the integral of 3t minus 1. So when you integrate 3t minus 1, what you're getting is 3t squared over 2 minus t plus some constant of integration. We can call that constant c. So that's the velocity. But it told us that the velocity is equal to 4 when t is 2. So when the velocity is 4, we're getting that it is to 3 times, time is 2, 2 squared over 2 minus t, which is 2 plus c. This will allow us to find what is the constant c. So the constant c works out to be, so work that out, 3 times 2 squared divided by 2 minus 2. And so c works out to be 0. Since c is 0, that means we can write that our velocity v is just 3t squared over 2 minus t. This is the velocity, 3t squared over 2 minus t. That's the velocity. Nice and easy. Now I want the velocity when t is 4. So when t is 4, we can plug in t as 4. We get v is equal to 3 times 4 squared over 2 minus 4. And that's equal to 3 times 4 squared divided by 2 minus 4. And so v is equal to 20. All right, and so when t equals 4, the velocity is 20 meters per second. That's it. That's how we find the velocity when t is 4. Nice. Now the next part of the question says find the displacement of the particle when t is 3. So now we need to find displacement. Now s, I call the distance x. S is equal to the integral of v. So we need to integrate 3t squared over 2 minus t to get the formula for s. All right, so when we integrate this with respect to t, 3t squared minus 3t squared over 2 minus t, when we integrate this, what we're going to get is s is equal to, add 1 to the power, so we get 3t cubed over 3 minus this becomes t squared over 2 plus some constant c. Nice, so this is the formula for s. But now we can find out, what we can find out now is we can find out what c is, because when s is 1, they told us that s is 6 when t equals 2. So s equals 6 when t is 2, and so 6 is equal to 2 cubed minus 2 squared over 2 plus c. And so this will give us c. So c works out to just be 2 cubed is 8 minus, let's see, 2 cubed minus 2 squared divided by 2 is 6. And so c works out to be 0. So what does that mean? That means that the formula for s is just t cubed. This is just t cubed minus t squared over 2. That is s, t cubed over t squared minus 2. Alright, that is s. So to find s now, and they want s when t is 3. So all we need to put in is when t is 3. So when t is 3, we're going to get that s is equal to 3 cubed minus 3 squared divided by 2. So all of this works out to be 3 cubed, as you know it is 27, minus 3 squared over 2 is 9 over 2, which is 4.5. And so s is working out to be 27 minus 4.5, that's 22.5 meters. So that is s. S is 22.5 meters. All right. So when t is 3, s is 22.5 meters. And that takes care of this paper. Nice and easy, soft. So as you can see, math papers, really easy, soft, a capital T.